Hello, hello. Can you read? Hello, hello. Okay, I can start. Okay. Good afternoon. Thank you to everybody to be here. I am Luigi Ghezzi. I am technical marketing engineer for Hamamatsu Photonics Europe. And today I will speak about image and linear sensor. In particular, I will focalize the attention on the ultraviolet and infrared sensor. This is the index of the presentation, so it's very short, don't worry. First of all, I will introduce Hamamatsu company. Later, I will focalize my attention on the visible sensor, for in particular the linear and image sensor that are the topic of today. And at the end of the presentation, I will introduce the infrared sensor and some application that can be used, where can be used this sensor, and how we can support you with our product. So let's start. First of all, I want to introduce Hamamatsu. I don't know if you know the company or the city, maybe that it's very famous for the motorcycles like Honda, Suzuki, and similar. It's located in Japan, basically here, you can see, 2 hours from Tokyo. It's an industrial city, and we are located in the same city, and the company take basically the name of the city. Okay. Here there are a lot of numbers, but I will try to highlight the main topic. As mentioned, we are a Japanese company. We are manufacturing optical components, module, and system. We have a very long history, 70 years. We are honored that we contribute to 3 Nobel Prize with our product, and we are more than 50,000 products. Basically, we have emitter like LED, PLD, QCL, but also lamps. We have detector, not only the image and linear detector that are the topic of today, but also photomultiplier or photodiode that we can provide like single or array detector. And we have also camera and optical system that we made directly in-house. And to this very large family of products, we have also a lot of customized products. We have a very good customized service, so we are able to provide also customized solution for our customer. Okay, as mentioned before, the topic today is the linear and image sensor. Basically, we have a very large family of sensors. We can cover all the spectrum of the light, from the X-ray up to infrared sensor. Today, we will speak about the visible sensor, so the highlighted in green, basically here, in the first part of the presentation. And in the second part of the presentation, I will introduce the InGaAs sensor. And in particular, I will focalize my attention on the near and SWIR part of the spectrum. Okay, let's start with the visible sensor. Basically, as maybe you know, at the start in the industry, the first approach for the inspection was the human approach. So the human make the inspection on the line. But with the increase of the product and the quality, need to have also sensor on the line. And the first approach was to use a sensor that see like a human, but without be tired and faster. For this reason, the first approach in the industry was about the visible, that it's the spectrum that we can see. Here I just mentioned some main application about the sensor, like for example, the shape or pattern recognition, the position detection, or the machine vision, but these are just the most common application that you can find in the industry. And when we speak about visible sensor, basically we speak about CCD and CMOS. Here there are a nice picture, I think, with the resume of the structure and the main characteristic of this sensor. In particular, I want just to remind that CCD are basically this is the photosensitive area, so we have a vertical shift register, and usually we have one amplifier at the end of the horizontal shift register. What means this? That basically we have one amplifier we have an output that usually it's an analog output. The external circuit to usually to drive this type of sensor, it's more complex. It's not possible the partial readout. And the real advantage of this sensor, it's the sensitivity and the dynamic range, that it's very large. In comparison, the CMOS are more easy to use. As you can see, the amplifier, it's in each pixel. So it means that we can have also an output that is digital and not only analog. It's very more easy to link the external circuit. And in this case, we can also use partial readout. But the disadvantage of this sensor respect to the CCD, it's usually the dynamic range and the sensibility. Anyway, in Hamamatsu, we make both sensors in our factories, and we can provide both solutions, depends from the application that you need. Here, for example, I want just to highlight some of the new products that we have developed recently. First of all, the CCD that from my discussion seems that don't need the industry, the CCD, but we think that this is not true, in particular for the detection in ultraviolet region, because as you can see, we suggest this type of sensor in particular for the ultraviolet application, like the checking of the tape or adhesive present on the line. And as you can see from the quantum efficiency, but we will see better later with the combination, the sensitivity and the dynamic range are very right and very, the profile is very, very clear. If we compare this with the CMOS, for example, here we have one of the last CMOS that we provide, you can see that the photosensitivity and the quantum efficiency are not so linear and are this type of behavior. And also the absolute value, it's not comparable usually with the CCD, in particular on the large spectrum. This is just an example of the last CMOS that we can provide for high-speed measurement. As you can see, we have 3 different pixel size and different configuration, depends from the application. I want to highlight another CMOS that it's very new and combine the advantage of the CCD with the CMOS. Basically, as you can see here, we have a spectrum that it's a smooth spectrum, so more similar to a CCD respect to a CMOS. And with all the advantage that I explained before. So this CMOS, it's easy to use and to link to the external circuit. We have also RMH sensor. And before to show you the lineup, I want just to mention it that our sensor don't follow the usual trend to have a large number of pixels, because we are more focalized on the measurement. And for this reason, we prefer to use few pixels with high sensitivity. This allows us to have a short integration time for the measurement. And this means that we can have an high frame rate that usually it's something very helpful for the measurement more than the pixel. Here, it's exactly the concept that I explained. This is our lineup. As you can see, we have ultra high speed sensor, or we have different configuration with the high speed sensor. And we can also provide this new sensor that is a CMOS, but it's optimized for the ultraviolet region. It's something very, very new. So it's interesting. Okay. With this, we close the part of the visible sensor and we go out of the visible sensor. As you know, now a lot of development make easy to see also out of the visible range that we usually use. And we can use the infrared sensor and infrared light. Here, I just mentioned some of the main applications that we can use with the infrared sensor. For example, we can see the material that is behind the lacquer, or in the fruit and food, it's very helpful to highlight the moist area that usually it's not detectable with visible light. We have also other applications, like, for example, the blood checker or the inspection of defect of a solar panel. This is just some example of the possible application, but infrared it's new, so there are a lot of new applications that are not yet used in the market. It's also very interesting to see the combination of these two types of sensors. For example, in the farm here, I use the example of the rice. I forgot. I have this. And this sensor can be used in combination. So, for example, we can use the usual visible sensor to detect the color or the shape of the rice. But in the meantime, we can use an in-gas linear image sensor to detect the foreign material like the glass or the stones. This is just one of the examples, but in the sorting, the infrared detection, it's very, very helpful also for the plastic, for example. How we can support you with our product, for sure. So this is the lineup of the linear image sensor. And in particular, I want to highlight the new sensor that we have basically ready. In August, we'll be ready in the market, but we already can provide some sample. And it's the G16125. The main improvement are in particular in the speed of the readout. We have 48,000 lines per second, and the previous version of this sensor, the G14714, have 40,000 lines per sensor. So we increase the readout, and we implement also the optical blank. So basically, some of the pixels are covered from this optical blank, and this allows us to have to reduce the noise, because basically we can use the readout of this pixel blanket to see the noise of the detector. We have also the area in-gas image sensor. Here it's a little bit complicated to read all the sensors. And also in this case, I want to show you the new family. It's this one, the G1656X, that basically cover all the spectrum from 0.9 to 2.5, but we will see this better later. And respect to the actual family that we can provide, we have an improvement in particular in the signal noise ratio, in the readout mode that it's not only integrate then read, but also integrate while read, and in the ROI function that it's described here. Basically, we go from the partial readout to the multi-line readout. As mentioned, this family of sensors are the ideal for the hyperspectral imaging. In fact, as you can see, the combination of this sensor can cover all the short infrared range from 0.9 to 2.5. And in fact, we have also a customized module that is exactly for this scope of the hyperspectral image, and all of us in one measurement to cover all the wavelength spectrum. For example, here we combine these three sensors and we cover from 0.9 to 2.5. This is just an example, but this is a customized module. So if you need particular sensor or other sensibility, we can change the sensor inside the module. So thank you for listening, and I am open for any question if you have. No? Okay, I think there are no questions. In case you have future questions, you can find us at 340. The bot is here in this hall. And thanks for your attention.